there's our decoder chip. And we can put that right in. That'll go right in there. And then we'll head over to the logic analyzer and see if this thing actually does something. We'll do a smoke test. All right, and here we are with the logic analyzer and a power supply. Hi, I'm the Troy McClure of Power Supplies. I appear in just about every video. Yeah, we know. And we're getting kind of sick of you. Okay, so I've got it set for 5 volts, and we'll limit it at 500 milliamps because we don't want to hurt it too bad if it does blow up on us. I've got the logic analyzer kind of set here. So we'll get these things hooked up. Oh, and actually, so I've got 3 ground leads. They'll go here. Notice I added a test point on the board for ground, which is a nice thing. I did make some, mistakes on this board, I'd say. They're not critical mistakes, but, and this isn't the first board I've made, so it's not like I didn't know better. I just wasn't thinking. But there are some chips, this one, and which one? There's a couple of them, where I actually labeled, the chip identifier, which is here, here, and so on, there. In this case, it's under the socket, so you can't see it. Same thing with that, so you can't see it. Makes it a little harder to, if you're going back sometime later and troubleshooting. Well, or, if the socket should happen to block your view of the part ID, just figuring out which one it is to plug the right chip into it can be a problem. So, recommendation, always put your part IDs outside the parts. Wherever possible. Okay, right, so we're going to hook this up. The power is not on right now, the power supply. Okay, trust me on that. So this is ground. Oops. This is ground. This is ground. And this is ground. Okay, and I want to put a signal, put a tracer. We'll trace the address lines and the ROM and RAM enable signals. Because the test program, well, I'll talk about the test program for a minute here. This is what's in the EEPROM. Starting address is FFFE on any reset, power on reset or whatever. And so these are all of the sort of interrupt vectors. So I've mapped them all to go somewhere so that if we should get an NMI, for instance, we'll know it by looking at the trace. So this is, reserved SWI3 and so on, come down here. Reset comes to here, D00E. Which is an address in the read-only memory. And the first instruction is a no-op. Then it's going to load the value of 10 hex into the A register. You'll store that in RAM location 0. And then it goes into a little loop here, decrement location 0. And if it's non-zero, it'll loop around. So we should see that loop 16 times. And then it just hangs. There is no halt instruction on the 6809, which kind of surprised me, because I thought every processor had a halt or halt and catch fire instruction. But this one doesn't, so I'll just be branching to its, it branches to itself. Okay. So as I said, I want to hook up the ROM and RAM addresses. And those are done. And now we'll put the clip onto the processor. If I haven't gotten this in the way here. Try to do this neatly. This is the clock. All the rest are address lines. And it appears to be on. Okay. So, anything else to do here? We've got ROM, RAM, decoder chip, CPU. That should work. So we'll tell that to run. Oh, well, okay, wait. We're running single trace. Start when you see a location of D anything. Okay, which is, again, where I have the code starting. Okay? So, power on. See what happens. Trace complete. There it is. Okay, so we went to D00E, which is correct for the reset. And then D00F. Let's see. So that was D00E did the no-off. That's reading ROM. D00F is the F10 and 1. No, F and 10. It's 2 bytes. Are that LDAA instruction, and then 11 and 12 are the store. Okay. And there's an extra cycle there, which is meaningless. But then you can see that it's storing, it's accessing RAM location 0, which is where I wanted it to store that value. And then we go 14, which is decrement. 14, 15, 16, because that's specifying the absolute address. Of 0. 14, 15, 16, there's an extra cycle. And then it reads location 0 in RAM, decrements it and writes it. Then we go to 17, 18, branch if not equal, back to 14, so we go to 14, 15, 16, 17, so we can see it loops through that a bunch of times. I'm not going to count them. I trust it's correct. If we get to D019 at some point. And so it's doing a bunch of them. There's D019 and D01A, and then D019, D01A. So there you go. It's now in that infinite loop. Using under 0.5 milliamp, so there was no magic smoke, and it's actually starting to look a little like a computer here. So what's next? Well, I've got to do more testing, obviously, get the I/O things working. I got a sound chip, I got a timer chip, and I've got a parallel port, and then of course get the video working, which will be the hard part, because that requires precise timing and stuff. But for now, that's progress.